For this lesson, we're going to be talking about exponential functions. And the first thing I want to talk about is the warm-up, and it's what form do we want things in before we graph them. And we've talked about this a bunch of different times, but we always want things in slope-intercept form. That's what we've talked about before, which is just basically solve for y. So we want to make sure we have equations solved for y. That's the important thing that you should remember. So when we talk about an exponential functions are, or equations, are functions that are in the form y equals a times b raised to the x power. Okay, a cannot equal 0, b has to be bigger than 0, and b can't equal 1, because that would give us something else. Now, here's a little bit different than stuff we've done. Our base is a constant, which means it's just a number, and the exponent is a variable. And then the important thing to understand here, exponential functions are nonlinear. That means they will not be in a straight line. They will always have a curve. So exponential functions have a curve. So some examples of some exponential functions are y equals 2 times 3 to the x, or y equals 4 raised to the x, or y equals 1 half raised to the x. The common part of an exponential function is you're going to see this raised to the x always. And notice each equation is solved for y. We can kind of think of that as being slope-intercept form. So let's go ahead and let's actually look at a graph of an exponential function. We want to graph y equals 3 to the x, and we're going to find the y-intercept, and then we're going to state the domain and range. To find the y-intercept is always where x is 0. So we're going to plug in 0 for x. So my y-intercept will be y equals 3 raised to the 0. And as we've talked about before with exponents, we know what anything raised to the 0 is. Anything raised to the 0 is just 1. So my y-intercept is going to be 0, 1. So I go over to my graph. 0, 1 is going to be my y-intercept. And then I'm just going to find another couple more points. So let's find a point where x equals 1. So we do y equals 3 raised to the first, or y equals 3. So I'd also have the point 1, 3, where x is 1, y is 3. And then let's find another point. Let's see what y is when x is 2. Y is equal to 3 raised to the second power, plugging in 2 for x. Get y equals 9. So my second point would be 2, 9. I'm going to plot these points now. I have 1, 3, and 2, 9. And you notice this is not going to make a straight line. This is what happens with exponential functions. They start going up very, very quickly, or they start going down very, very quickly, depending on which way you're going. But they're always going to be a curve, so you just kind of approximate what that curve will be. And that's not perfect, but that's an estimate of what an exponential graph would kind of look like. The important thing I want you to understand here is that it will never cross over the x-axis. An exponential graph will never cross the x-axis, which means it will never be negative. The exponential graph will never, ever be negative. So when we're stating the domain and range, for my domain, the domain is all the x values I can have. Well, you can see it's going to go forever to the right and forever to the left. So my domain goes from negative infinity all the way to infinity. Or another way to say this is all real numbers. I can plug in anything for x and I'd still get an answer. I could plug in 2 million, I could plug in negative 5,876. It does not matter what you plug in for x. Now for the range, here's where it gets a little tricky. We said this will never cross the x-axis, so it will never be negative, which means it will never be smaller than 0. So we know my range goes from 0, but then we see it keeps going up forever and ever, so it goes from 0 to infinity. Or another way to say this is all real numbers greater than 0. So basically we're doing the exact same thing that we've done before in graphing. It's just instead of having a line, we're going to have this exponential function, which is going to have a curve in it. Your domain, all real numbers, negative infinity to infinity for x. Your range, though, exponential functions are never negative, so it will only go from 0 to infinity. It will be all real numbers greater than 0.